All right, on simplifying expressions with radical exponents, there are a lot of rules that you have to know um, to be able to do this. First off, let's just start with your exponent rules. So if you have like bases and you're multiplying them, x and x are both the same, you will add your exponents. If you are raising a power to a power, you multiply. If you are dividing like bases, you subtract. And I think that's it. But we're doing all this with fractions. So real quick, fraction review. Fractions. When you add or subtract, you have to get like bases. So if I add 1/2 plus 1/3, I have to change this so I have a like base. So 2 and 3, their least common multiple is 6 because I can multiply 2 times 3 to get 6. But what I do to the bottom, I have to do the top. And I can multiply 3 times 2 to get me 6. So then I add across the top 5 and then keep the denominator of 6. So 1/2 plus 1/3 is 5/6. And that's the same thing with subtracting. You have to get like denominators. Next, you have multiplying fractions. When you multiply fractions, you just multiply across the top, across the bottom, and simplify. So if I did 1/2 times 1/3, I would get 1/6. So just know across the top, across the bottom, adding, subtracting, common denominators. Or use our calculator that has a fraction in it. The yellow calculators that we have in the class love fractions. So there you go. All right, so that's what we have to know to be able to complete this section. So first off, when you multiply two bases, you add their exponents. So we have to add 1/3 and 1/4. So 1/3 plus 4/3. I don't know what I said. 1/4. No. So that's in the exponent. We're adding them. There's already common denominators. So 1 plus 4 gives me 5/3. Write your answer as a radical and simplest form. So the bottom's my radical, my index, the top's my power. Simplest form. So we got to simplify this. X cubed, x to the 5th, one group of 3 with 2 left over. One group of 3 with 2 left over. Yeah. And I'm going to rewrite that. There, that fits a little better. All right, same thing on the next one. Add like bases. So this is going to be p to the 1/4 plus 3/4 halves. Common denominators, we can get this to 4, and then I'll have the same denominator as this one. So I'm going to do p to the 1/4 plus, to get that 2 to be a 4, I have to multiply by 2. So I have to multiply by 2 on the top and get 6. So add them together. 1 plus 6 gives me 7/4. As a radical, this would be the 4th root of p to the 7, and then we have to simplify. 7 p's, if I group them in 4, I have one group of 4 with 3 left over. All right, so good so far. When we divide like bases, we subtract their exponents. So this is m to the top one first. Remember, order matters, minus the bottom one. Common denominators, we can get this into a 4, so that would be 10/4. 10/4 minus 7/4. So 10 minus 7 is 3. Keep the denominator. So the bottom is my root. So this is the 4th root of m to the 3rd. When I raise a power to a power, I multiply. And you just multiply across the top, across the bottom. So 1/3 times 5 halves is 1 times 5 is 5. 3 times 2 is 6. The bottom is my root. The top is my power. I make this look very easy because I know what I'm doing, but it takes a lot of time to understand this. So 32, when I raise a power to a power and multiply, 1 half times 1 half. 1 times 1 is 1. 2 times 2 is 4. So this is the fourth root of 32 raised to the first power. And I think 32 can break down. So 2 and 16, 4 and 4, 2 and 2, 2 and 2. Yeah, there's 4 twos, 5 twos actually. So if I have 5 twos and I'm grouping in 4, one group comes out and one stays in. All right, when I raise a power to a power and multiply. Now be careful here. This 8 is also being raised to the 2/3. So I'm going to go ahead and just write it in a radical form first, because this is the cube root of 8x squared squared. There's two ways to do it. We can square everything in here and then take the cube root of it, which I think is what I'm going to do. Or you can take the cube root of 8 and then square that at the end. So I'm going to square everything. 8 times 8 is 64. Raise the power to a power and multiply. So that's x to the 4th. And then I have to simplify it. 64 is 2 times 32. 32 is 2 times 16. 16 is 2 times 8. 8 is 2 times 4. 4 is 2 times 2. I am not trusting myself. I'm going to check myself in calculator. 1, 2, 3, 4, 5, 6. 6 twos. All right, just checking myself. 2 to the 6th is 64. So let me pause it. So I know this is right. And we're grouping in threes. Every 3, 1 comes out. Every 3, 1 comes out. Every 3, 1 comes out. So 2 twos come out, which is 4. This is x to the 4th. So I can have one group of x's. And then there is still an x in the cube root. Okay, another exponential rule that you have to remember is negative exponents, because that's going to be like the next half of this. So I should have added that here. My bad. So remember, with negative exponents, we'll select x to the negative a. To get rid of a negative exponent, that is a fraction. So 1 over x to the a. Or if it's already on the bottom, x to the negative b, bring it to the top and it'll become positive. I love negative exponents because it was explained well to me. And so I want to explain it well to you guys. Okay, negative exponents. So first off, let's just do a chart of regular exponents. I usually have my class start with this and say, okay, which one do you know? They're like, oh, 2 squared is 4. 2 cubed is 8. 2 to the first is 2. And then they usually say 2 to the 0 is 0, and that's obviously not right. But what you see here is 2 times 2 gives me 4. 4 times 2 gives me 8. 8 times 2 gives me 16 if I want to keep going. But we're not worried about that way. We're worried about the other way. So if you go to the right, you multiply, then go to the left, you divide. So 2 divided by 2 is 1. So that's why anything raised to the 0 is 1, because you're dividing that number by itself. And if I go again, I'm dividing. 1 divided by 2 is 1 half. 1 half divided by 2 again is 1/4. So what you see is you're taking these positive exponents and putting it on the bottom. So 2 to the negative 3. Well, this is just 2 to the 3rd underneath 8. All right, so negative exponents, negative 1 half. It's not happy where it is. This whole thing's not happy, so it has to go onto the bottom. So 100 to the positive 1/2. And it's going to the bottom of 1. And then we'll change it. So that's 1 over the square root of 100. 2 is my index, 1 is my power. Neither of those have to be written. And we know the square root of 100 is 10. So 1/10. All right, we're taking the cubed root of 16 squared times, this is negative, so I'm going to drop it to the bottom. It can go to the bottom of this fraction. The cube root of 16. So it's the cube root of the whole thing. So this is the cube root of this whole thing. 16 squared is 16 times 16 over 16. Well, 16 over 16 is 1, so that cancels out. So we're just doing the cube root of 16. And break it up. 16 is 2 times 8. And I can keep breaking 8 up, but 8 is a perfect cube. The cube root of 8 is 2. So 2 cube root 2. So all of this goes to 2 cube root 2. All right, not happy where it is, so it's going to go to the bottom. You're just changing the sign of this, not the number. So this is still the negative 216, and it is the cube root of that number. Remember, with negative, if it's an odd root, the negative can just come out because a negative times a negative times a negative is still a negative. So this is 1 over negative cube root 216. Oh my goodness, I don't know what 216 is. 2 and 108, 2 and 54, 2 and 27. So 2 times 2 times 3 times 3 times 3, 216. So actually, that's a nice cube root then, isn't it? The cube root of 216 is 6. That's my plan before I knew it was just 6. So that equals 1 over negative 6. Negative. And that negative can be with the 6, can be with the 1, or can be out front. Choose one. All right. If this is a negative and you're raising the fraction to a negative number, you're going to put that 1 over 112 over 7 to the 1/4 positive. But instead of doing that, you can, when you divide by a fraction, you multiply by the reciprocal. So that just means you flip it. So it's 7 over 112 to the 1/4. Okay. So this is the 4th root of 7 over 112. Now we simplify. 7 over 112, let's see if that simplifies. I don't think it does. Oh, it does. 1 over 16. So the 4th root of 1 over 16. And then you take the 4th root of the top and the 4th root of the bottom. 1 times 1 times 1 times 1 is 1. So the 4th root of 1 is 1. Any root of 1 is 1. And 16 is 2 times 2 times 2 times 2. Let me make sure. 2 times 2 times 2 times 2. So the 4th root of 16 is 2. So all of this just goes to 1/2. With just numbers, a lot of the time you can check them in the calculator. So I can even go 112 divided by 7 to the negative 1/4 is 1/2. And that's great. But when we get to ones that don't simplify nicely, 16 to the 2/3, I think it was negative 1/2, negative 1/3. You get a decimal. And so, I mean, you can check that your answer to cube root of 2 is the same decimal, but there's no way to get this calculator to convert, or any calculator I know of, to convert it into the simplest radical form. So I can check that they're equal, but I can't check that this is the right answer, if that makes sense. All right. Keep going. But when you get to variables, you just have to know how to do this work. You can't put this in a calculator because you can't put variables in the calculator. So I'm going to change this. What's our instructions? Make sure I'm doing. Rewrite all radicals in exponential form. Use the exponential rules to simplify the expression. Okay, we want to write this in the simplest exponential rules. So we need to actually convert these to rational so we can combine them, because this is cube root and this is square root. But you can multiply this together. So this is v to the 1/3 times v to the 1/2. When you multiply like bases, you add their exponents. I think I actually did this already. Where's 1/3 plus 1/2 is 5/6. So this is v to the 5/6. And leave your answer in a radical form. So this is 6th root of v to the 5th. So this is simplified because I went from 2 radical forms to 1. All right, again, write them as rational exponents so that we can combine them. And then when I multiply like bases, I add their exponents. So 3/4 plus 1/2. I'm going to go ahead and make this 2/4 because that's 1/2 with a common denominator. Add across the top, 5/4. Got ahead of myself. R. So this is the 4th root of r to the 5th. And that can be simplified 1 group of 4 with 1 left over. All right, last 4. Rationalizing. Remember, you can't leave a radical in the denominator. So I actually have to multiply to get this out of the denominator. We really only talked about squares. So since this is cubed, we actually need to do a group of 3 to get it out of the radical. So if I multiply by the cube root of 16, then I'll have a group of 4. A group of 3 since this is the cube root. When I do the bottom, I have to do the top. You cannot multiply that 4 in because it's outside the radical. So this is 4 cube root. I'm going to go ahead and put 16. And then 4 times 4 times 4. I want to say 64. I don't know. But I'll have a group of 3, so the 4 comes out. You can simplify 4 over 4, cancel that to 1. So this is 1 cube root 16. And then you just have to break down cube root of 16. 16 is 2 times 8. 8 is 2 times 4. 4 is 2 times 2. Oh, cube root, every 3, 1 comes out. So this is 2 cube root 2. Rationalize, no radical in the denominator. Actually, the denominator canceled out. So, all right. You can rationalize by multiplying both of these by square root of 7. But with our division rule, you can simplify the fraction first since they're both square roots. So this is saying 7 times 7 times 7 all over 7. So that equals the square root of 7 times 7. And 7 times 7 is 49. Every 2, 1 comes out. So it's just 7. Guys, how you practice math is if, like, you get this. You think you get this. Pause the video right now. Try this one on your own. And then play the video through and make sure you got it right. Or watch where you got it wrong so you understand. So I'm grouping 10 x's in groups of 4. Then I'll get 2 groups of 4 because that'd be 8 x's. And then I'd have 2 left over. And make sure you put that 4th root there or this answer would be marked wrong. This doesn't simplify at all. I don't know what it wants for me. Because 25 is 5 times 5. M squared is m times m. That's it. Can't do anything with that one. And sometimes you can't. So it's just that answer. All right. Today you have a Delta Math and a quizzes. Delta Math, just so you know you're getting it right or wrong before you do your quizzes. Let me know if you have any questions.